Hello everyone, welcome to iTower. Today we're diving deep into event handling in JavaScript. Every time a button is clicked, a page is scrolled, or an element is hovered over, events are being triggered. JavaScript manages these interactions through a mechanism that allows code to respond dynamically. Event listeners play a crucial role in this process, capturing user actions and executing the appropriate functions. Event propagation determines how events move through the DOM, affecting parent and child elements in different ways. Understanding these concepts helps to write more efficient and bug-free code while avoiding common mistakes when working with events. Let's break it all down step by step. First, let's understand what an event actually is in the context of JavaScript. An event is something that happens in the browser, usually triggered by user actions like clicks, key presses, or form submissions. But events can also be generated by the browser itself, for example when a page finishes loading or when the window is resized. JavaScript allows us to listen for these events and define specific actions in response to them. Let's start with the most common way of handling events, using the addEventListener method. This method allows us to attach a handler function that will be called whenever a specific event occurs on an element. Let's look at a simple example where we listen for a click on a button. What we have here is a simple button with an ID of myButton and a div with an ID of output where we'll display some text. Now let's add our JavaScript to make this interactive. First, we need to select the button element. We will use the querySelector method to find the first element that matches the CSS rSelector. The hash sign indicates that we're looking for an element with that specific ID. This method will return the button element, which we store in a variable called button. Now that we have a reference to our button element, we can add an event listener for clicks. We select our output div just like we did with the button. Then we use the addEventListener method on our button. This method takes two primary parameters, the type of event, click in our case, and a callback function that will be executed when the event occurs. Inside this function, we're changing the text content of our output div to indicate that the button was clicked. When we run this code and click the button, you'll see the text in the div change from waiting for click to button was clicked. This is a basic example of event handling in action. But here's our first potential issue. What if the button doesn't exist on the page? You should always check if your element exists before adding event listeners. This additional check helps avoid the error that occurs when you try to add an event listener to a non-existent element. When an event occurs, JavaScript automatically creates an event object containing information about what happened. We can access this object by accepting a parameter in our handler function. In this code, I've modified our callback function to accept the event object as a parameter, typically named event. I'm logging the entire event object to the console so you can explore its properties. Then I'm displaying the mouse coordinates where the click occurred using the event's horizontal position and vertical position. These properties give us the horizontal and vertical position of the mouse pointer when the event was triggered, relative to the browser window. The event object contains a wealth of useful information. For example, event type shows the type of event like click, key down, and mouse over. Event target is the element that triggered the event. Event current target is the element the event listener is attached to, and event default prevented tells us whether preventDefault has been called. Speaking of preventDefault, let's talk about that. Some elements, like links and form buttons, have default behaviors. For example, clicking a link will navigate to a new page. If you want to stop this default behavior, you use preventDefault. Let's add a link to our HTML. In this code, I'm first selecting our link element with querySelector. Then I add a click event listener that calls preventDefault, which stops the browser from navigating to the URL specified in the href attribute. Instead, we update our output div with a message. When you click the link now, you'll stay on the same page and see the link click prevented message. Be careful with preventDefault though. Overusing it can lead to a poor user experience since you might be breaking expected element behaviors. For example, if you prevent the default submit event on a form, make sure you provide a clear alternative or feedback. Now let's explore a very important aspect of events in JavaScript, event propagation. Events don't just happen on a single element, they can also bubble up or capture down through the DOM tree. This leads to two phases of event processing, bubbling and capturing. Let's look at this with a simple example. I'll create a nested structure with a parent div containing our button. By default, events bubble up from the target element to its ancestors. This means if you click on the button inside the div, the click event will first trigger on the button, then on the div, then on the body, and so on. Let's see this in action. We will add click event listeners to both the button and its parent div. The button's handler changes the output text, and the parent's handler appends some to whatever text is already there. When you click the button, you'll see both messages indicating that the event bubbled up from the button to the parent div. First the button's handler runs, then the parent's handler. This is important to understand because sometimes it can lead to unexpected behavior, especially when you have nested event handlers. You can change this default behavior so that the parent processes the event before the child. This is called capturing and can be enabled by passing true as the third argument to addEventListener. Now when you click the button, you'll see text from parent because it handles the event first in the capturing phase. This happens because we've set the third parameter of addEventListener to true for the parent's event listener, which makes it use the capturing phase instead of the bubbling phase. Also, sometimes you don't want events to bubble up, so you can stop this using stop propagation. When you click the button, you'll only see the text from button. The parent's click handler won't execute because we've stopped the event from bubbling up. This prevents the event from reaching parent elements, which is useful when you have nested elements with their own event handlers and want to avoid unwanted behavior caused by bubbling. But use stop propagation carefully. It might lead to unexpected behavior if other developers expect events to bubble. Additionally, it might break functionality of JavaScript libraries that rely on event bubbling. Instead of adding event listeners to every element, you can add a single listener to a parent element and use event target to determine what was clicked. This is called event delegation and is particularly useful when working with dynamically added elements. Let's modify our HTML to include a list where items can be added dynamically. Now we can implement event delegation in JavaScript by first selecting the necessary elements. We need a reference to the parent element, the add button, the list where new items will be added, and the output div where we'll display the clicked item. We also initialize a counter to keep track of the number of items. Next, when the add button is clicked, a new list item is created with a text label that includes the current item count. This new item is then appended to the list, making it visible in the DOM. Instead of attaching an event listener to each individual list item, we take a more efficient approach by adding a single event listener to the entire list. When an item inside the list is clicked, the event bubbles up to the list itself, allowing us to check which element was actually clicked. If the clicked element is a list item, we extract its text content and display it in the output div. Additionally, if the clicked item contains the word initial, we update the output to indicate that this was one of the original items in the list. This method is highly efficient because no matter how many items are added dynamically, only one event listener is used. When you click the Add button to generate a new item, and then click on any list item, you'll see a message displaying the selected item. Since the event listener is attached to the list rather than each individual item, newly added items automatically inherit the click functionality without requiring additional event listeners. Event delegation is particularly useful when working with lists or tables where elements can be added or removed dynamically. Instead of attaching separate event listeners to each item, we attach one to the parent element and determine the target of each click event. However, keep in mind that event delegation only works with events that bubble. Some events, like focus and blur, do not bubble by default, but you can use their bubbling alternatives, focus in and focus out, when needed. Next thing is that sometimes you need to remove an event listener, for example if you added a handler temporarily or if an element is no longer needed. For this to work, the function must be stored in a variable. This prevents memory leaks when working with many event listeners. Memory leaks can occur if you add many event listeners and don't remove them when they're no longer needed. This is especially important in single-page applications where a user might stay on one page for an extended period. Note that remove event listener only works if you pass the same function you used with addEventListener. This means anonymous functions cannot be removed. If you want an event to fire only once, use once parameter as true. After the first click, the event listener automatically removes itself. This is useful for events that should only fire once, such as initialization or animation-related events. Another important aspect of working with events is performance optimization. Adding too many event listeners can slow down your page. Here are some tips for optimization. Use event delegation when possible. Instead of adding listeners to every element, add one listener to a parent element. This is particularly useful for lists or tables. Don't add event listeners inside loops unnecessarily. If you're adding handlers to many elements, consider using event delegation. Use throttling or debouncing for events that might fire very frequently, such as scroll, resize, or mouse move. This prevents your handler function from being called too often. For example, here's how you might implement debouncing for a scroll event handler. This code runs the handler function only after the user stops scrolling for 300 milliseconds. This significantly reduces the number of function calls and improves performance. Now let's look at some common mistakes when working with events and how to avoid them. One common issue is incorrect usage of this in handler functions. The context of this in event handlers can be confusing, especially when using arrow functions. Arrow functions don't create their own this context, so this in them refers to the context in which they were created. This can lead to errors if you expect this to refer to the element that triggered the event. Another issue is ignoring passive event listeners. For events like touch start or wheel, you can use passive listeners to improve performance. The passive true parameter tells the browser that you won't be calling preventDefault in this handler, which allows the browser to optimize event processing. This is especially important for mobile devices. A third common issue is excessive use of events. Sometimes developers add too many event listeners or use inefficient selectors, which can lead to performance problems. This delegation approach significantly reduces the number of handlers and improves performance. And finally, forgetting to remove event listeners. If you add handlers dynamically, remember to remove them when they are no longer needed. This is especially important when you create and remove elements dynamically. If you add handlers to elements that will later be removed, make sure you remove the handlers before removing the elements. We've covered a lot today. Event handling in JavaScript is powerful but can get tricky with bubbling, capturing, delegation, and performance concerns. We've discussed how to use addEventListener to attach event handlers, how to access the event object for details about the event, how to use preventDefault to stop default actions, how to understand bubbling and capturing, how to use stop propagation to prevent bubbling, how to apply event delegation for dynamically added elements, and how to remove listeners when needed to avoid memory leaks.